Hope you all had a good break. Many of you, I guess, had a really good break because I didn't even upload the homework till this morning because nobody told me that it wasn't there. Anyway, so 213A we did on Wednesday. That was like 2 weeks ago. It was due this morning. But because I didn't get it there, so make sure you get it uploaded. Right? It was like a big worksheet, but we only had to do like A and B. Okay? So we're going to do C. Is there a D? I don't know, whatever. We're going to do the rest of it today. So we kind of, I don't know if we got hosed or whatever, but there was an extra B day. Anyway, so 13B today, 14 Wednesday, 15 Friday, review, test. So you kind of have to wrap your head around chapter 2 or unit 2 or whatever you want to call that. Okay? Because we're testing pretty soon. So there's not a whole lot of days. So you need to kind of go back, make sure you review, do those things. We had a couple of quizzes, and you got to get those done before here if you want to redo those. Some of you guys missed it, so your zeros are really hurting your grades. Okay, so if you got any questions about that kind of stuff, make sure you let me know. Send me an email. If you can't sign up, let me know. I'll pull whatever. Okay, all right. Today's bad. So focus. Before we did go for break, 213A, we were solving logarithmic equations. Pretty big topic. Hence why we broke that up into two. Today we're going to be solving inequalities today. That's a different deal. But you got to know how to solve equations in order to solve inequalities. So thinking back, I know it's been, like I said, I know it's been a while, guys. That worksheet, I've gotten to where I don't post answers anymore just because I'm getting a bunch of you guys just copying that stuff. And it's just obvious. And so I can't trustfully post answers anymore without people just copying it. Plus, I mean, you know how to check it now anyway. I mean, there's so much stuff out there you can check stuff. Heck, you can find these worksheets probably. So anyway, I don't post those. If you want the answers, you kind of have to work for them. Anything that I need to look at on those, worksheet A or worksheet B. Like I said, I know it's been a while. Worksheet A. Here it is. We got to solve them, right? So get these things uploaded. There were 12 solving there. 12 more or 10 more there, 8 more there. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8 more. Those are good. You're going to see questions like that, guys. Those are like free response type questions. Those aren't just multiple choices. There are multiple choices also, but I know there's a free response question solving for logs. I know that. Yeah, I told you guys, they'll tell you what the free response questions are. Number 4, solving for logs without a calculator. I know that. We'll practice that too, for sure. But that was A, and then B was pretty much the same thing. Key, worksheet B. That was just evaluate without a calculator. Those you got to get real good at too. You just got to, because what's going to happen is when you solve one of these, you're going to get down to something like that. And if you don't take it down the next step, you're going to get dinged. Right? It's just like leaving something that's like the square root of 4. You don't ever leave anything the square root of 4. You turn it into a 2. If you ever see log 10, or log 100, you better know that's 2. If you see 1/9 to 27 or 1/9 27, you got to know that that one's harder. Do that one in my head. That one's 3. You just got to know those things. And then solving some more. Solving. So get good at solving logarithmic functions. I know you guys are pretty decent at it because some of you guys did it on the last test when you didn't even have to. You got to use your calculator last test. If you have a calculator, you don't need to show anything. Just graph the left side, graph the right side, and see where they touch. Or move this side to this side and find the x-intercept. And that's how you can check these answers too. Probably wouldn't hurt to get good with your calculators. All right, everybody okay? Good, 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 good. So focus around. Again, like I said, coming up quick. Whoops, you don't want to see that. You want to see this. All right, part B, or part 2, or whatever. He calls it part 2. We call it part B, or I call it part B. Exponential and logarithmic inverses and inequalities. And inequalities is, that's going to separate the men from the boys and the women from the girls, or whatever. That's where we're going to separate the A's and the B's and the B's and the C's and C's and D's. Previously, we looked at inverse functions and finding inverses of given functions, including exponentials and logarithmic functions. We had the exponentials, y is equal to b to the x, and then the logarithmic, y is equal to log base bx, yada, 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 yada. Now we're going to look at finding inverses of exponential and logarithmic functions in general form. So, general form of exponential and logarithmic functions. Here's an exponential, a b to the x plus h plus k. Of course, the k moves things up and down, the h moves things left or right, and the a stretches or dilates it, I should say. Same thing, that a dilates it, that h moves it left or right, and that k moves it up or down. So you guys are somewhat comfortable, I hope, with logarithmic and exponential forms. We can write inverses by determining the inverse operations and reverse mapping, yada, yada, yada. So to find inverses, we're going to switch x and y, solve for y. Switch roles of x and y, use inverse operations to solve for y, write the final using correct notation. Oh, that's important too, that -1 exponent. When you solve for an inverse, you got to put it to the -1. Okay, here we go. Here we go. Draw. Find the inverse of. So the very first thing I do on this is when I see f of x is equal to something, I put y equals, because if it says find inverse, I like y, not f of x. And then I got 3, and then I got parentheses, and I got 2, close parentheses, x plus 4 minus 15. And if we're going to solve for inverses, we got to switch x and y. Switch x and y. So this is now going to be x, and this is going to be y. Plus 4. And now we just got to solve that for y. And that's not a whole lot different than what we did earlier, other than we didn't have 2 variables. So I think the first thing I would do is move that 15 over. And after I move that 15 over, I divide by 3. And so if I move the 15 over and divide by 3, I got 5. Y is equal to 2. Y to the 2 to the y plus 4. 2 to the y plus 4. Say again? Oh, sorry. X minus. Uh-oh. So I'm going to have x over 3 plus. Thank you. I don't know if it's better to have x over 3 plus 5 or x plus 15 over 3. Y'all see what I'm saying? I don't know if it's better to leave that all as 1. So it'd be x plus 15 all over 3, or leave it like this. I don't know if that matters. But that's another option. Everybody okay with what I'm saying, right? All right. So to solve this for y, I got to get it from being an exponent. And to get it from being an exponent, I need to write it logarithmically. Because currently it's written exponentially. Why do I know? Because I don't see the word log. If you don't see the word log, it's not logarithmically. So the only way to get that y back down is to rewrite it logarithmically. So here we go. Let me change this color, try to clean this up a little bit. All right, so this is log. Base 2 of all of this, I'm going to change that back to that x plus 15 all over 3. So change it back or not change it or whatever. I think that looks a little bit cleaner. Is now equal to the exponent y plus 4. And now it's pretty simple because all I have to do is subtract the 4. A lot of times, guys, when you get stuck, like I don't know what to do, typically you're going to rewrite it. Either rewrite it exponentially or rewrite it logarithmically, because most of the time it's going to clean it up. And so now I just got to put that 4 over here, and you can put it on front or you can put it on back. They don't care if you want to put it on front or put it on the back. If you put it on the front, it'd be -4 plus all this. And if you want to put it on back, it'd be this minus a 4. Just make sure you keep the parentheses where they're supposed to stay. And then you got to rewrite that. So I'm going to change that back y, change it back to f of x. Okay, change it back to f of x, and then put the -1. So I'm going to write log base 2 x plus 15 all over 3. And then I got the minus the 4 equals f x to the -1. And yes, you will get dinged if you don't write the -1. Yes, you'll get dinged if you don't change it back to f of x. We just, as we're doing that, guys, we decide this is not the perfect answer. It's not the only answer. I could have put the 4 over here. I could have still x over 3 plus 5 inside of the parentheses. I don't think that simplifies any more, any better, any different. Okay, questions? Switch x and y, solve for y, and then put it back in the correct notation. If it says find the inverse, I should have the inverse notation. Not bad, I hope. I hope that's not bad. Find the inverse. Here we go again. Find the inverse. So this is y. I'm going to go ahead and switch that. So x equals -3 log base 5 y minus 4 plus 6. Subtract the 6, divide by -3. I'm not going to do what I did last time. X minus 6, divide by -3. I could make this cleaner. I will. Y'all okay? Everybody okay? I know I did. Subtract the 6, so it's x minus 6, divide by -3. I would change this to 6 minus x over 3 just to clean up the negatives. Typically, they don't like negatives in the bottom. If you want to put negative outside, you can. But basically, there's a positive, negative, negative. Why not make it a negative, positive, positive? Clean it up. I know you guys are used to seeing x first, but you're cleaning things up by making things less negative. I got to get y by itself. Loop it. Loop it. 5. This is nasty looking. Let me change the color again. Green. 5 to all of that junk. I put in parentheses. You don't have to put in parentheses, but I put it in parentheses just to make sure you understand all of that's to the exponent. And then I switched that up just to clean it up. It's not wrong to leave it like this. Don't get me wrong. It's not wrong to leave it like this. And if you're concerned about that, leave it. You're better leaving it than trying to simplify it and get it wrong. add the 4, rewrite it correctly. So you got all this stuff. Man, I better do it. 6 minus x over 3. Then I got a big plus 4 equals f negative 1 x. Beautiful. If you can solve equations, you can do this stuff. There's not a whole lot different, right? I mean, our lesson the other day was pretty much we had a number right here and we were solving for x. If you had a number right here and you're solving for x, it's pretty much the same steps. It just looks nastier. Notice it was logarithmically, now it's exponentially because they're inverses of each other. Oh, right? Logs and exponentials are inverses of each other. You can make this one hard or make it easy. You can take 15 minutes on this, or you can take 1. Probably not 15. So read carefully. H of x equals 3 to the x plus 1 minus 2. So you have h function. K of x is the inverse of h. K of x is the inverse of h. So some students, test pressure, you're going to immediately turn that into an inverse. Don't. Just read, we'll see what happens next. For what values of x does k of x equal 1? Okay. K of x equals 1 basically is y equals 1. Y equals 1 for k. K is the inverse of h. So if k is the inverse of h, and that k is 1, or the y is 1, that must mean that if they're inverse of each other, and that's y is 1, then that must mean now x is 1 for the original. So rather than try to find an inverse and do everything else, all you got to do is plug in 1 for x. Yeah, that's a lot of understanding. H of x equals this. K of x is the inverse of h. So here my x's and y's are just switched. K of x equals 1. Y equals 1. Y equals 1. So if y equals 1 here, that must mean x equals 1 here because they're just switched. So rather than try to find the inverse or anything else, I'm just going to say h of x equals 3 to the 1 plus 1 minus 2. And therefore, h of 1 equals 7. 3 squared is 9. 9 minus 2 is 7. Don't leave it like that, though. Go back over here and say k of 7 equals 1. Because that's what they asked. What values of x does k of x equal 1? They'll accept this because your x equals set bless. This is what you're looking for. X equals 7. But this really that shows it. And this is, again, guys, where I don't try to circle your answers because that focuses that grader on that answer. Just kind of leave all 3 things, and all 3 of them are right. None of them simplify any differently. My guess is they're either looking for this or this. I don't think they're really looking for this, although it says the same thing. H of x equals this. K of x is the inverse. K of x equals 1. Y equals 1. Y equals 1. So if y equals 1, that must mean x equals 1 over here because they're inverses. If you can soak all that in, you're good. Beautiful. All right. Here we go. Previously, we solved inequalities of polynomials and rationals. I don't know if you remember solving for inequalities and rationals. Hopefully you do. When you solve for inequalities, you have to make those sign charts and figure out if it's positive or negative here. If it's positive, it's greater than 0. If it's negative, it's less than 0. To do this, we first find any x coordinates where the functions had zeros, holes, or vertical asymptotes. You found zeros, you found holes, and you found vertical asymptotes, and all those were values that we tested. We tested to the left, and we tested to the right, and we tested to the left, and we tested to the right, and we tested all those points. Then we used a sign chart to determine intervals where it was positive or negative. We have to do the same thing here. We can solve inequalities involving exponentials and logs the same way, except it's actually much simpler than working with exponentials and logarithmics, believe it or not. That's what he says. Example number 4. F of x equals log x squared minus 4x plus 7 minus log x plus 3. Find all the values where f of x is greater than 0. F of x is greater than 0. And f of x is two different things. So I need all of this crap to be greater than 0. Let me go ahead and write that. That'll get you a point just by doing that. At least you recognize that that function has to be greater than 0. Anybody got what I should probably do first? Hit me. Simplify the logs. Man, if I can make something simplifier, we'd simplify it. I got a log of something minus a log of something, and we learned one of those rules. If I have a log of something minus a log of something, I can make that 1 log with the x squared minus 4x plus 7 over x plus 3. Y'all have more room than this to work? There's a reason. I got to start copying y'all stuff. How I do it is how I teach it, but how I teach it gets confusing for students. Don't let this confuse you. Like, why the heck did you do that? I don't really care currently when it's greater than 0 or when it's less than 0. I care about when it is 0, and that's where I'm going to make my sign chart. And those values that I find are the ones that make it 0. And then I'm going to find the values to the left and to the right and make it plus or minus. And if it's positive, then it's greater than 0. And if it's negative, it's less than 0. Y'all kind of follow all what I said. Let me repeat all that. I didn't really switch that, but I kind of did, because I don't care about greater than or equal, because I need a sign chart. And so in order to find a sign chart, I got to care about when it's equal to 0. Okay? And I'm just trying that on this one. Let's see how it goes. This is base what? 10. 10 to 0. What's 10 to 0? 1. So can I just write that as 1? I don't have a whole lot of room. That's why I'm doing all this. So 10 to 0 is 1. I don't think it matters. It doesn't. That's another reason why I do it. Some students say 1 equals this, and other students say this equals 1. And if you have the inequality symbol, that messes things up. Y'all follow what I'm saying? Like I don't know if 1 is greater than this, or if this is greater than 1, the way you rewrite that. So that's why I just changed it to an equal sign. I'm going to have to use more room. There's no way for me to get this on there and make it look clean. Blank. X squared minus 4x, x minus 3. Okay, we're here. What I do? Multiply both sides by x plus 1, x plus 3. Got to get rid of it. If I do something to one side, I got to do it to the other side. X plus 3 is real nice times 1 because that's just x plus 3. So now I have x plus 3 equals x squared minus 4x plus 7. Some of you knuckleheads are going to move this 4 over here and move that 3 over. No, it's got to be equal to 0. Got to be equal to 0. So you got to move this x over here. And you got to move that 3 over here and set it equal to 0 and hope this thing factors. I got there. Thanks. Whew, really good thing, because if it was minus 4, it didn't factor. Most of the time, that's going to factor for you. Most of the time, it's going to. It may not. If it doesn't, you got to use a quadratic formula. But luckily, this one does. Okay. So here's my little sign chart now. Positive 4, positive 1. 1, 4. Gosh, I don't know when I throw the trick in there. Or the catch. One of my students used to call it, what's the catch? There's a catch in this. Let's just go. Let's go with this right now, and I'll try to talk about the catch. I got to go back, so let's go back. Where am I at? Here. I guess I better do it here. Less than 1 is 0. Less than 1 is 0. 0 squared, 0 plus 4, that's a positive number. In between 1 and 4, I can test 2 or I can test 3. I'll test 2 because that's a smaller number. 2 squared is 4. 4 minus 10 is negative 6. Negative 6 and 4, that's a negative. You guys have done enough quadratics to realize that if it's positive over here, it's probably negative over here because that's a 0. Bam. And then that's a 0. So this better be positive over here. But if you don't recognize all that stuff, test a point. 5. 5 squared is 25. Minus 25 is 0. Plus 4 is 4. Plus. Everybody okay? All right. Don't get too excited. Here's the catch. So let's go back. Where am I going back to? I got to go back to here. So this was what? This was positive, negative, positive. And I want it greater than 0, right? here's the catch. If this was a polynomial, we would say from negative infinity to 1. And then we would say from 4 to infinity. If it was a polynomial. But it's not a polynomial. Remember, it's logs. And what can we not take the log of? Negative numbers. You can't take the log of 0, and you can't take the log of negative numbers. You can't. That tells me right there that x has to be bigger than negative 3. There's no way x can be smaller than negative 3, because if it is, this makes it undefined. That's bad. So really, this is that catch part. I was kind of trying to decide on when to talk about that, and I guess I always look at it as part of the answer. There's no way it can be smaller than negative 3. If it is, that makes me have an undefined answer. So the values that will make this thing greater than 0 are from negative 3 to 1. It can't be brackets, because if it's brackets, it's equal to 0. And from 4 to infinity. Okay, first thing I did was combine that together, and then I rewrote it exponentially, and then I found the values where it's greater than 0 or less than 0. I did a sign chart. My answer should be from negative infinity to 1 and from 4 to infinity, because those are the two pluses. But that's where you start. You got to use in your mathematics and your answers, knowing that you can't take the log of a negative. And if you can't take the log of a negative, there's no way I can go from negative infinity to 1, because it can't be smaller than negative 3. Because if it's smaller than negative 3, that's bad. That's why you always have to check your answers on these. Check for those extraneous solutions. And those are kind of like extraneous until I get to negative 3. And as soon as I get to negative 2, I'm okay. Or just on the other side of negative 3, I'm okay. I don't have to worry about this part here. Luckily, I don't have to worry about that part, because all those values, if I plug all those values in here, I should check, but if I plug any one of those in, that makes it plus. So we're okay. All right. Just when you think you got it, you got a lot of room on this one too? More than I got? G of x is natural log of that number, and h of x is the natural log of that number. What values of x for which g of x is less than h of x? I don't know, that may be a little bit easier. I don't know. I want g of x to be less than h of x. That could give me a point just by writing that. Could. Now we have the previous example. If the natural log of something is less than the natural log of something, then the somethings have to be less than the somethings. Follow what I'm saying? This is not right mathematically, but it works. Man. Most of the time it's going to work out fairly nice. They're not testing if you know the quadratic formula. Always remember this up here, though. Knowing there's no way it can't be smaller than -4, for sure. Yeah, this question's so freaking hard. I made it look easy. Golly, -3.5. -3, well, I can do -4. Doesn't matter. I can do -4. -4, that's negative, that's negative. Negative times negative is a positive. Positive is not less than 0. Positive. X, whatever you want. However you guys want to do that. It's positive, so it's wrong because I want less than 0. 0. 0 plus 3 is 3. 0 minus 3 is -3. Positive times a negative is a negative. Negative is less than 0. That works. Golly, how am I going to? Four. Positive, positive, positive times positive, 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 not less than. This is positive, this is bad. So according to my answer, it's from -3 to 3. But that's not right. I don't think. I know it's not right. Because what values between -3 and 3? 0. There's a lot of things between -3 and 3, right? 0. 0 is 1. 0 squared is 0. 0 plus 0 is 0. Minus 5 is -5. So I'm taking the log of a negative. You follow what I'm saying? So I can't go from -3 to 3 because there's some undefineds in there. Gosh. Yuck. Golly. Yuck. I'm telling you, I told you this is going to separate you. Delete. So here's what you got to do now, knowing that. Plus x minus 5. I got to figure out when this is greater than 0. Because that can't be smaller than 0. Because if it's smaller than 0, I'm taking the log of a negative. I can't take the log of a negative. And crap, that doesn't factor. Negative b plus or minus b squared minus 4ac over 2a. Y'all got that thing memorized somehow, yes? You know a song or something? Y'all know a song? You don't know the story? Do you know the story behind it? There's a story behind the quadratic formula. It's not a good story, but it's what I know. It works. Where's my clear one? I'm going to get in trouble for this. Oh, hey, good morning. Thank you so much. Or don't thank me, but thank Mr. Sharp. How do you have two of these? Cool. All right, so here's my story. There once, way back in time, was a bad, a bad boy who was very indecisive. He could not decide or want to go to a radical party. This boy was a square dude. So because he was square, he missed out on 4 awesome chicks. And the party was over at 2 a.m. Shut up. Greater than 0. Sing your little song. Did I do that right? Minus 4ac. 21, -1, plus or minus the square root of 21 over 2. Yuck. And this is without a calculator, guys. This is without a calculator. I know. I know. Quadratic, yes? Quadratic. So that opens up, yes? So it opens up and it hits the x-axis somewhere and it hits the y-axis somewhere, but one of them's -1 minus that and one of them's -1 plus that. Kind of okay? So just kind of, you don't have to know exactly what it is, but kind of get an idea. But -1 minus the square root of 21. Well, the square root of 21 is like 4 point something. Because 5 is 25 and 4 is 16. So it's 4 point something. So -1 minus 4 point something is 5 point something. And -5 point something divided by 2 is like -2 point something. Yeah. -2 point something. -1 plus 4 point something is 3 point something, and 3 point something divided by 2 is like 1 point something, but it's positive. Fair enough with all I'm saying? And so this graph looks like that. And so in between this negative and this positive, this graph is negative. Boy, this is a lot of stuff you have to kind of just see it and kind of think. It's a quadratic. It opens up. You have an x-intercept of whenever this is minus, and you have another x-intercept whenever this is positive, or whenever you do the plus. When you do the minus, you get the positive. You get the 2x. I'm not saying it's not always, zero's not always in the middle. Zero's not in the middle. But I'm not saying that zero, I'm not always saying that it's here and here. It could both be down here. Or they both could be up here. You just kind of understand that. It just so happens that they're one on the right side and one on the left side. Anyway, we learned that this is the bad part. So now I finally have my answer. Because what did I go to? What did I actually start at? -3, right? Because we said originally it was from -3 to 3, but it can't be from -3 to 3 because of this area right here. So I got to go from -3 to that, which is this minus, and then I got to go from this to 3. Boy, maybe I'm making a big deal out of this. I don't know. To me, this is kind of hard, but you guys are freaking smart, so maybe it's not. Maybe I'm making a big deal out of nothing. So I'm going to go from -3 to -1 minus the square root of 21 over 2. And then I got to go from -1 plus the square root of 21 over 2 to 3. Are you going to get some points if you go from -3 to 3? Yeah. Are you going to get all the points? No. Told you it separates the A's from the B's from the C's, the C's from the D's. I don't know which one it separates. Well, it depends on how you did on the rest of the test. If that's the only thing you missed, it might separate an A from a B, but it may not. But depending on if you missed some other stuff, it could separate an A from a B. If you missed a bunch of other stuff, it could separate a B from a C. Y'all follow what I'm saying? That's why you guys, you always have to check these things when you got logs. That's why all your answers, you got to just be, because they're not going to tell you. They're not going to tell you to check for extraneous solutions. You just got to know. Anytime you're solving for a variable and you got this stupid log thing, you got to check for these extraneous things. You have to. And that's what's bad, is because you guys work your butts off because you finally figured out, ooh, at least I can do this and I can do this. Oh, that works nice. Good, I'm done. No, you're not. You got to check. And these homeworks are really important, guys. Really important. You got to. K of x, what are values where k is less than -31? I need k. Now, do I need to worry about extraneous here? No, I'm not taking a log of anything. Fair enough. Y'all follow what I'm saying? I'm not taking a log of anything, so I don't have to worry about extraneous here. X can be anything, because this goes from -infinity to infinity. This domain is -infinity to infinity. 1 minus 4 parentheses 2 to the x minus the 3, and I want that to be less than or equal to -31. Subtract the 1. Divide both sides by a negative. Actually, I'll divide by a -4. Oh, that's so nice. Subtract 1, that's -32. Divide by a -4, that's 8. Whoops, I got rid of the 4. Y'all might need to show more steps than I'm doing. I just don't have as much room. Is that the right math? Now you can go the easy way or the hard way. You got 2 to something that's less than 8, but you can make 8 2 to 3. So I would make this 2 cubed. Now you got 2 to something is less than 2 to 3, and that way this something has to be less than 3, which is really, really nice, because if I move that over here, now this x has to be less than 6. And so I'm going to go from -infinity to 6 equal bracket you can check always. 6 minus 3 is 3. 2 to 3 is 8. 8 times -4 is -32. -32 and 1 is -31. -31, it's equal. So that one's not too hard. I didn't have to make a number line for that one. Is that the last thing? What else is there? Is there something else? Oh, you do have the extended? Oh, dang, I didn't think they put those in there. I was going to give that to you as a quiz. Well, let's look at it. You still might see it as a quiz. Let me tell you where you think you will see this. Because on the AP Pre-Cal exam, free response question number 4, you will require students to solve various logarithmic and exponential functions without a calculator. That's the AP exam. That's what you're going to have to do. So we're probably going to do that. Below are part of the directions for students will see. That's part of the directions you're going to see for the free response questions, along with 2 sample of questions that could appear on one of these free response questions. No calculators allowed. Determine the exact value of any expression that can be obtained without a calculator. For example, log base 2/8 can be written as 3. In other words, you better do that. If you don't, you're not simplifying it. Combine like terms where applicable. For example, 2x plus 3x, you better write as 5x. 5 squared times 5 cubed, you better write as 5 to the 5th. You don't have to tell me what it is because it's a non-calculator. No way you should have to multiply 25 times 125. Just tell me it's 5 to the 5th. X fifth over x2, you better know that's x3. ln 3, ln 5, better be ln 15, not ln 8. Those should be all equivalent because those are simplified. F of x is this nasty thing. Solve for f of x is equal to e to the 1/2. Yuck. So f of x equals e to the 1/2. So e to the 1/2 is f of x, and I want that equal to e to the x to the 5 over e to the 1/4. Yuck. And there's 28 of you cats in here, and there's 28 ways you can do this. And I don't know which way's easier, and I don't know which way's harder. But all 28 of you better end up with the same thing. You can multiply both sides by e to the 1/4. That's not wrong. You can subtract exponents. That's not wrong. You can move this over here. That's not wrong. You could do all kinds of things to it. When you get done, we better know what x is. I think the first thing I'm going to do is make this e to the 5x, because that's a power to a power. So I'm going to leave this as e to the 1/2. I'm going to make this e to the 5x, and this is e to the 1/4. And I think I'm going to go ahead and subtract. No, probably easier to multiply both sides by e to the 1/4. You can subtract, multiply, I don't know. You know what? It may be easier to subtract for you guys. I don't know. That's what makes this hard. I did this. Well, okay. Just don't do something wrong mathematically, and it's okay. You might want to do this. You might say e to the 1/2 is equal to e to the 5x minus 1/4. That might be nice, because now you have e to something is equal to e to something. And then the somethings have to be equal, because this is just subtracting the exponents here. That's e to the 5x, and that's e to the 1/4. You can subtract exponents because you have the same base. I think if you multiply both sides by e to the 1/4, e to the 1/4, e to the 1/4, that cancels that, and now you add the exponents. 1/4 plus 1/2 is 3/4. That might be easier. I don't know. E to the 3/4 equals e to the 5x. Hopefully you can kind of see the common thing between these two. They're going to be the same thing. But now you got to set the exponents equal to each other. So basically 3/4 equals 5x. Up here, I would have had 1/2 equals 5x minus 1/4. And if I move that 1/4 over here, I got the same thing. Divide both sides by 5. And so if I divide both sides by 5, divide by 5 is multiplying by 1/5. However you do it, you got to end up with 3/20. And 3/20 doesn't reduce. It's a different way of testing if you know the rules of exponents. G of x equals that. G of x equals 3e. Find all the values for e that are in the domain. 3e equals 8 e to the 3x minus e. "28 different ways." Well, I hope everybody at least adds e to both sides, probably as the first step. Divide both sides by 8. Boy, I wish that 2 wasn't there. Just erase it. Just get rid of it. Makes it a whole lot easier, right? I know, I am. Oh, he didn't get it? Oh. I'm stuck. When you're stuck, you better rewrite it. Rewrite it logarithmically. Except I'm not going to rewrite this one logarithmically. I'm going to rewrite this one naturally logarithmically because it has the e's. In other words, take the natural log of both sides. Okay with that? If I take the natural log of one side, I can take the natural log of the other side. Does that help me? Natural log of e is 1. How'd you do that? That's the rule. That's the rule. Kick that 3x out front. 1 equals natural log of 2 plus 3x. Can I just drop the natural log of e? Because natural log of e is just 1. Told you, got stuck. Subtract the natural log of 2. I kick the 3x out front. I don't think that simplifies any. I don't think that simplifies any. You could make it 1/3 minus natural log of 2 over 3, but I still don't think it. Yuck. Okay. I spent more than I wanted to today, but that's all right. I missed you guys. Let me hit this button here.